but still because of these things in the lecture slides and everything, you will use in that. Or sometimes most of the industry situation, we won't use these names most of the time. Beside, there is some sort of documents called as SRS and FRS. So we are using in that part sometimes, but in the coding level, if you are in the software engineer developer part, we are mostly not using those words in real world. But when come to the documentation, definitely we are using that. But and finally, I'm talking about the third point, that coding interviews and contests. So mostly interviews and contests are the things that are harder to go. Then if you are selected to something and everything, you can figure it out how the things are going. But the first foundation that you have to build is that when you're first facing the competition, definitely you have to go through the question and problems. And the second one is the interviews. If you are going to the development environment, so you have your coding interviews will be really hard in most of the companies. So that's why the three parts that you want to learn about data structures. The, the usage of these things in your work environment or your studies in order to pass your examinations and coding labs, tutorials. And another two is finding a job. You're passing the interview. The another one is that your this competition, the IEEE extreme, or the competition that going to help by your university as well. So these are the things why we need to learn about more about problem solving and data structures in the foundation level. So the first point, the right tool for the problem, what that means. So people say we need to use arrays, we need to use trees, we need to use their graphs, hash tables, or something like that. Is that the thing that meaning of that right tool? Actually not, right? So if you are in a boarding place, if you are a student, if you are in a boarding place, most of the boarding place doesn't have a nail, uh, a hammer. Okay, in order to put a nail, you don't have a hammer. But sometimes our friends have some sort of that component box, even like we have screwdrivers, some small screwdriver or something like that. Screwdriver also works, right? So if you want to nail something to, let's say your girlfriend gave you some sort of a picture to put in your room, then you have to nail something to it and do something from there. So in order to do that in the boarding place, we doesn't have that hammer, right? The big thing that we put nails in the wall. So we don't have that one, but we have a screwdriver. So using the screwdriver, we can also do the similar task, right? So we can put a nail in using the screwdriver as well. But what is the problem in there? So the issue is when you are putting the nail, we require more energy and it will take some risk to our hand, or sometimes the screwdrivers, that other part will be damaged. So those kind of situation we will face if you use a screwdriver. But the scenario is we can use that. You can use that and solve that problem we have. So that's why I'm talking about data structures, why we need that. You doesn't need that learning about that graph into that end level to use that one. Or you can solve that problem using just an array. That's a fine. But it will cost you something. Okay. So when we are coming to the contest, like programming competitions, we have limited resource. Even in the industry, if you are getting a project, we have limited resources. So when you are going a project, they will tell you have a 4 GB RAM and you have this kind of a CPU, you have a Linux server, you have a Windows server, something like that. There is a specification document for that one. So in there is a limitation for those kind of situations. So based on that, we have to develop the application to the end. So in a problem, there is a timeout sequences or memory allocation. It is different from language to language, but the difference between that time and memory in based on language, basically based on what is the compilation time based on that language that they are using. So based on that, that will be changed, but we have a limited time and a memory to the each question. So when you are talking about that, so we have to use a better data structure to solve that. I will talk about using the data structure in the later, but I need to tell you that choosing the right tools matters when it's come to solve any sort of a problem in your life. So that's the one condition. You have to learn about these data structures. You have to solve the specific problems with the given time and with the given memory capacity or the CPU processing time. Based on that, that's why we have to choose the better data structure for the each and every question. So the second one, so I talk about third one and first one together. The second point, what is this reduce time and space complexity? So mostly people are using like this, right? So even in your lectures and before the parts that they have talk about what is that o1 is better, o1 on is not, on power to the 2 that is worse. Maybe they have talked about those things. I will let you know that what is this on power 2 or this into the power 2, or people will call it on log n. So these are how we are measuring the time and space complexity that is in the word. So I will tell you with an example, right? So let me know that if you can see my change in screen, how this will change. Give me a sec. Okay. Can you see my screen, that white screen? Can anyone confirm that you can see this one? White screen without anything?
Yes, we can see.
Okay, great. Okay, so if you are using a for loop, right? So if you are using a for loop, it's mean n. Okay. For example, I am telling you about the second point, how you are. And if you have to use a for loop within another for loop, it's another n. So n times you have to do that. This is n times you have to do. Normally, when we have these kind of thing in solution, we are calling it like n to the power n. So not to the n to the power n multiplied by n. So it will comes as a to the power 2. So normally as a developers, we doesn't like this part. Okay. The reason is that this is very slow when we are coming to. So this will be issuing lot of problems in the future. So for example, let's say you have a table that contain lot of data. Okay. In that table, you have a button like this icon. What is this? Mostly this icon represent as download some option. So let's say you have to download a Excel. So if you are using this kind of algorithm, so you are going through the each and every data and put every data into your Excel. Let's say you are using a npm package or something like that. From there, you are writing some sort of a for loop to getting all the data from each row and putting all the data into another Excel file, CSV file, then downloading that file into your local computer. So in that situation, if you use something like this, for if you let's say you have 10 data, okay, only 10 data, this is working fine, that you will not get any sort of problems. Okay. So if you are a developer, so normally in that program, in the industry, there is a developer and then there is a QA. Okay. When we develop something, this goes to QA. So in a competition, this means that you are a competitor and you are putting it to some sort of a cloud platform. Okay, you are a competitor and you are putting into a cloud platform. In there is a small computer in the cloud, so they have very limited memory and the CPU. Then they are running the program that you have given, the solution you have given to them. So in the development environment, the industry, we call this person as a QA. So he or she is testing the application we have developed. So when they do the load testing, this going to fail. It's mean if you have 1,000 data, let's say this one will be 5,000 is this. let's say 10,000, this is also fine. But when it comes to 1 million data or more than 100,000 data, that's going to be a problem. So the function that there doesn't have any issue. The solution you have given, there is no issue. But the only reason that you have your internet browsing speed, or in your internet speed, or your computer CPU speed. If it is a program that you are running server side rendering, something like that, or what is your server's capacity? Based on that, that simple download option will give you an issue, really big issue. So even if that will be downloaded, and there will be a no issue in downloading phase, but you doesn't contain all the data that you have requested at that time. So now in a competition, this way you will see some sort of test cases will be failing. Let's say some may fail because of a timeout, some may fail because of memory exceeds. Okay, in the industry, this QA person will raise a ticket for developer. Ticket mean that they are mentioning there is an issue. Okay, it's best if you are the developer, you know you have created this kind of useless code, that not useless, actually very bad code. Okay, so if you are the same developer who are fixing that issue, that will be fine, because you know, okay, I have used something like this, I have to correct this part. But think about that, you are normally working as teams, right? Even the competitions, if it is IEEE extreme, you are not sometimes the same person who are solving that. When you are giving a solution, your friends try to optimize that and do that one. Okay, so let's say if you are a friend besides you, that's fine, you can talk about this part and solve it together. But if your friend working with online situation, so same as the you are working in the industry, there are multiple developers. So if the, let's say the other developer is in, let's say in Jaffna, so you can't meet him and let him know this is the thing that you have given. Or let's say you have used ChatGPT and try to solve the problem. ChatGPT has generated something like this, and you directly put into the answers and getting, now you have to debug this one. Debug this one means this is working fine, but it doesn't give the output that you want. It means you can't get the 100% from this question. Or if you are in the industry, you can't pass from the QA phase. So another developer going to look at your full code, and he first has to come to a situation like this, figure it out, this part, why this is not working. So even the function is without issue that is running, the logical part also working. The only reason is that server is the problem. So this developer telling your DevOps, there is a role called DevOps. Okay, there is no issue in my code. You have to increase the memory or CPU. In here, in the competition, you can't tell the competitors like that, right? Right? The ones who have created the question, you can't tell that I can't have the memory. So you have to increase the memory in order to run my code. You can't tell like that. The only reason, okay, you are speaking skipping this question, or you are trying to figure it out. If you have a better understanding about these data structures, how they are working, then you will optimize this one. So in the industry as well, you doesn't go to the dev and update the servers as well. You just optimize this function, then it will output the relevant data, and it will execute the thing that you really want to get a real output from that one. So that's why we have to learn about these, reducing time and space complexity. Okay, so I think I have cleared these questions regarding that one. So let's get back to this. Okay. Okay, so we have covered all the three why questions, why we need that data structure. The first one is to figure it out the right tool, and the second one is to uh, solve the looping situation, telling the blaming the other persons and everything. So the third one is to get you a job and to win some sort of a contest in that part. So these are the three things that why you need to learn about data structures. And let's dive into the first thing, the king, the arrays. So most of the people think this is a index based access. It means it is a some sort of a index based storing mechanism. There is a 1 2 3 4 5 6, and there you can put some sort of a value into there. Technically that is right, but that's not all about the arrays. So with this arrays you can do really big things. Okay, so the even if you are a senior, the experts, the first thing you are going to do when you see a problem, try to solve it by an arrays, because that is the, I'm not talking about 2D or 3D arrays. When 2D and 3D arrays, it's going to be really hard to visualize. So when you are getting a 2D, two dimensional, it's going to be really, it's fine still, but it's when you are visualizing that part, it's going to be really hard. In that cases, you will definitely move on to some sort of different data structures. That is the downside of the array. So when you are learning about those arrays, when you are solving some sort of a problem, when you are going your step by step situation, let's say you are putting, you are really good, uh, what it called like wipe code. So wipe coder means the until the AI free package is running, you are best developer in that phase. So if you are that kind of person, or you are a person who are getting your pencil and book and break down the problem and try to solve it each by each, or you are a developer, something like when you see a problem, this is the only thing I know, I will start from there, then let's see what will happen next. So that is, if you are that kind of a developer or that kind of a problem solver, so any person who are always trying using arrays, okay, even in the experts, the moment it's going to be a 2D array, that senior person, the expert person, is going to change that 2D array and move on to a different data structure. But most of the other persons who are using vibe coding, or you are really good, what is that we are calling like using prompt engineering, they are trying to solve, okay, I see a problem, okay, it has been solved, we have to use 2D arrays and 3D arrays, okay, he's going to optimize his script, then doing that again. So that will also fine, but it will lead to some sort of issues that you can't figure it out edge cases, because in order to find a very small point, you have to visualize the whole system. If it is a 3D array, uh, it's really hard to visualize what's going on inside. You have to have a better understanding about memories, better understanding about the relationships between that parts in order to understand. And if you develop something like that, learning how to that kind of a problem, let's say another junior developer or something like that, come in and look at your code, even to him to understand that kind of complex situation, it's going to be really hard. So your learning curve also going to be really bad in that situations. So as I told you before, arrays is the king that every person goes to until it's going to a 2D or 3D arrays. We can use multiple uh, algorithms to solve these questions using just an array. It's not just an index based storing system. With the proper techniques, you can figure it out any questions, any solution for any questions. Okay. So I will give you an for example. So let's say, for example, let's get the boarding based student again. So he has a good days and bad days. Okay. So good days I means financially. Okay. This is a financial situation. Uh, Normally you are getting, let's say you are getting some sort of amount from your family or your part-time job when you are in the university. You have to figure it out which your streak means which days continuously you are saving some sort of money. So let's say the first day you are getting 700, second day also 700. For a month you are getting each day 700. Okay, so each 700, how much you are going to spend? If there is a positive, that is a good day. Okay, so if you are getting your girlfriend's birthday or your friends going out for some thing to do, so those kind of day you are going minus, that is bad. Okay, so let's say good and bad days. So when you are going to figure it out, that streak that you are getting, that okay, continuously 4 days I will get a this kind of, I can save this kind of sum. When you are getting these, then you have to figure it out which was the biggest sum that you have get. Okay, so in this case situations, most probably, let's say this is you can see my IntelliJ, right? I hope you can see this one. So let's say you are going to figure it out which was the biggest money that you have saved in that month. Okay, normally if you going to solve these kind of problems, let's say that is the one of the questions that you are getting, most probably you are going to use in that ON2 problem, ON power to the 2. This kind of situation, it's mean you are using two for loops. It's mean you are going to solve this using brute force. Brute force means you are trying to figure it out every combination that you are going to do. So no, most people do that kind of situation in those kind. So for example, you will figure it out this kind of code to as a solution. So you can see there is a for loop among another for loop. This will give you the really good answer solution for this one. This is really fine. You can enter some sort of a data. This will working fine. Okay, but this is really time consuming and waste of our memory. So you have to have one memory and you are doing a loop, not memory, sorry, the CPU time. Okay, so this will use most of your CPU time, and this is very slow mechanism, because if it is a month, that's fine, we can figure it out what is the largest amount that we have saved. But if it is a year or a 2 year, it's going to be really hard. Okay, so this is not a good approach to solve that one. Still we have used an arrays for the solutions. Okay, so normally we are going with that. So how many guys think that we have to change the array and go into some sort of a different part to solve that one? If you can raise your hands, then that's fine, or otherwise I, how many guys think that we have to switch to another different data structure to solve this kind of problem? No one? Okay. Yeah, right. No, and that we don't have to actually go to a different data structures, because this doesn't give you the output that we want. We just need to use some level of different technique to solve that. That is called as cutting algorithm. So cutting algorithm is that talking about that you have to use the maximum sum, and when you hit a bad day, when you hit a minus point, you just have to reset something. Then you continue in that only one loop, and when you figure it out something like that this is bad from the sequence, we just reset and again do that one. So that kind of solution is going to look like this. Okay, there's no two for loops in here, just one. From this one you can just solve. So this is what I'm talking about. So if you can't understand, this is I'm using just my go-to language is Java, but when you are problem solving, the easiest code lines, the limit of very few codes line are using either JS or Python. The scripting languages are the very small amount of codes you can use and solve the situation. So there is no best uh, let's say a language to solve something, that it is like that most familiar language. If you are going to solve some problem, if it is in the competitions, I suggest you to use that most comfortable language you are in. So in here Java, there is no typecasting or something, sorry, Python, there's no types, so you can easily access as well as, sorry, as well as it will give you some sort of errors in the long run as well. if you doesn't specify which part is which. So mostly that's in JS, okay? JavaScript, if you are using JavaScript, when you are using string manipulation, or if you are adding some numbers or you are doing something like that, you have to cast it very well. Otherwise, it's going to be a different output because of the language, not because of what you have written, the solution you are getting. Because of the language loopholes, you will get some sort of issues. Trust me, I have failed in my industry years. In the program, I developed something that it leads to a lot of problems later on, not because of the answer, because of the language, that weakly type language that I have used to solve that situation. So for the language doesn't matter, but you have to careful with that part. But try to solve any questions based on the language that you are most familiar with, even if you are generating it with chat gpt or something. So arrays, so cadence algorithm, I talk about this part, uh, these two things, right? If you can't understand with the codes, I will tell you with the other as well. So in the arrays I will talk about lot, but after that we can talk about very how to delete this one. So the thing that later on we will link list and JavaScript, I will talk about some sort of a high level update on regarding those parts. Not going to the deeper how the memories and nodes memory allocations are working. So if I do that, we can't end this within next 2 hours or something like that. It will take around 10 to 12 hours. Okay, for example, let's say there is a data like this. Okay, 2, 5, -2. These are the amounts that you have saved each day as a student in the university. Okay, like this. Okay, so I am getting like a simple table like this based on our code. I'm talking about this algorithm part. You can simply understand, you are getting all in here, every loop you are considering every sub array and figure it out if it is max or not, or going through like. But in here we use same array, but we have changed the technique of how we are doing this one, and this technique called as cadence algorithm. And it will just reset in something like this. I will show you that we have used two variables, right? This is, we have used one extra memory to solve these slow progress. And we will, in here also there is a local variable same as that, but in here I have used same variables but has a different more memory than. I have to save more memory in here in order to give you the better answer for here. For, let's say this is the current sum in the algorithm, and the max sum is the one we need. Okay, maximum is the max, total sum is the need that what we need to figure it out, which was the structure. Okay, so first of all, everything is one. I'm getting this, there is the first day, your current sum also the one, and the maximum, the first day is the value is one. So since your that day it is one, your current sum also one, and the maximum also one. And let's get the second date. So we are figuring out which is the best out of, when we get the max value between this number and when we add these two numbers, the current value and the previous value. So current and right? Not the plus, sorry. Either 2 or the total amount we are getting. It says it is -5. So in here, the answer will be 3 is bigger than 2, since our current sum is 2, and the max sum also we are getting like maximum between the current sum and the previous max sum. So 3, sorry, current sum is now 3 or the 1. So obviously 3 is the bigger. Likewise, we are doing to the whole part within a single loop. We are checking the maximum values and storing based on that. So we are changing upcoming the and in here, let's see, the 3 is 10. So obviously the 3 is bigger, but the current value is 2 minus 2. But what will be the bigger value? Still the 3, right? So we are not resetting the maximum value. We are continuing this maximum value. And in here, the maximum value stays the same. But our current value is changing and we are figuring it out every time. So let's say if it is, this one is a 9, you can see if our this value is not bigger than our current value, the current num value, this one will be the only option. Okay. So far, this is the best approach we are getting. The why I am telling is this is still 3. We didn't came to some sort of a reset point. If we are getting to the 9, you can see, let's say I have doesn't have 2, just 9. If we put 9 in here, we are figuring it out. Now we only have 3 from these two. These two. We only have 3 and we are getting 9 in here. So it means this streak will be closed. And this will be the streak we are starting. From 9, then we are having some sort of a plus value. Then we are continuing from here. From the algorithm, when we are using this kind of algorithm, that we will drop that extra for loop that we require to change that value. So we have current sum here, we have maximum sum here, we are continuing this one until we are continuing this one until we hit something like that in here, that more than that maximum value is higher than the current value. So this will replace that value and resetting that value and updating our subarray again. So likewise, using these kind of things will help you to, without changing the full data structure, just putting some sort of an extra part in there, you can figure it out that better solution. That we are calling this as not that optimization. The people say that refactoring or optimization is not like optimization. This is the solution that you are getting. That is the before you are using that as a beginner, normally you are using always brute force. That you are figuring out everything like a simple manner. But that when you are hitting that second for loop, you have to figure it out. Okay, I messed things up. This will work fine, but this doesn't give me the result that we want. So when you are getting the expert in this area, so you will figure it out that kind of area. So okay, now I come to the second for loop. Okay, this will be going to the next one. So likewise, so when you are having a if conditions, if else, if else, if else. Okay, now I am getting a messed up. If we have to go through every tree, every structure in the if else. So let's say there, if you are using if else for 10 times, that is not a best coding practice. So you have to switch into a switch. So switch method, you have a switch and one case. So program will be faster. Otherwise, if you have if else conditions, let's say your answer is in the 10th else if one, you have to go all through every single line to figure it out that else if part. So it is not like that. It is not 3. Let's say you have to figure it out whether if it is 10 is the even. So if you use a if condition for that one, you have to check 1, 2, 3, 4, 5, 6. Likewise, it's a better solutions that you can use a just divided by 2 and figure it out. If there is a reminder, then you can figure it out. But let's say if you are using that if condition, the switch is better than if, because even that switch condition, you only in the compilation time, it's only going to the one case. So if you are using that technique, if else, if else, if else, that is really bad. So you don't have to change the data structure because of the solution doesn't give you the what output. But if you can use some sort of algorithm combining with that, that you will get the different solution that you will expect. Okay, so that is about arrays. So it's not just just to summarize, it's just not an data index type. You can combine with a different approach and use the same data, that basic data structure, and give you a better solution for that one. Okay. Now I won't talk about list. List is the basically data array with some sort of a reference to it one, and it has a different approach. Let's talk about trees. So when we are talking about trees, the first thing you have to come to your mind is hierarchical. Trees are more when we are using to solve some sort of a hierarchical problems. The reason we are using hierarchical problems, let's say you have to figure it out that who is your longest in your tree longest relative who doesn't have your blood connection with that longest one. So in that cases, if you use some sort of a linked or array or something like that, that doesn't have the connection between that relationship between that nodes. Nodes mean there is a two paths, that connectivity, the relationship between. If you are using array, there is an index based something. So for example, bookshelf. In there, let's say there's 8 books in Harry Potter. You have to figure it out. You have to get the fifth book. Okay, in that case, you can go and grab the fifth one and do that. But there doesn't contain any sort of a relationship with that series of Harry Potter, right? It doesn't have the fifth book doesn't contain that. If you are getting the fifth books, I'm not talking about the story in the library bookshelf. If you are getting the fifth books, it doesn't have a contain between the first one, right? Unless if you put some sort of a label, this is Harry Potter, so in order there is a 1 to 5, 1 to 8 connection between that, then you can have that one. But unless that, you doesn't have a connection between the previous book and the next book in there. So in order to solve these kind of situation, you can use a tree. So mostly family trees we are talking about. But these trees, even the first year students are using without knowing. Okay, you guys are without knowing you are using these trees. I will show you the what you are talking about. Okay, when you are talking about trees, you will know about that node and the parent, like that one, right? So you are talking thinking about the connection between some sort of a round thing and one sort of a edge case like this. So you are talking about something like this. If we, when the first thing that you are getting into a tree, you think something like this, the balanced tree or BTS or something like that, something like this, right? This is the first thing that you come to mind. If you are talking about trees, if you know about data structures, the thing that you are seeing always is something like this. But I will tell you, the first student I ever did, you use this without even knowing. I will show you. If you inspect this one, and I inspect this one, so let's something like this. If you inspect this one, this is also a tree. Okay, even with you are not knowing thing, most people are using trees. Okay, if you doesn't have this kind of tree, you can't figure it out how to use this. Let's say in here, you can figure it out this part, right? You have to go through every div to figure it out. Let's say if you didn't use something like this, you just code that HTML file. This is we are calling as DOM tree, okay, document tree. So in here in Chrome extension, now they have that tree view as well. If you didn't use this view based thing, in order to figure it out, a button between something like you are putting, let's say, some sort of a CSS. So if you are going to change this CSS into red or something like this, okay. So if you want to change the color, because of I am going through that each part, I can do that changing in the tree, right? So this is in under this one. If I doesn't have this kind of tree, one line, if you put and slash in and put code the single HTML file like that, if you change something like changing this color to hidden to something like that, overflow to hidden or something like that, it will change full page. Okay. It will change every part. If you it's like putting some sort of a css property to into your body in the html. So this will ruin that part if you have one line. So that's why even if you doesn't know that you have used trees since your first year in the web development, you have used this one. So that is a one example, real world example, that you have already used that trees. So you have to have a connection between this list time and your uh, above div tag in order to find this list item. Okay. So what I meant was that in order to find this li, you have to figure it out that ul first, then the div, because you will have direct connection with this li, right? So likewise, this is not exactly the tree that you have to think about. There are some multiple types of trees that you have can use. Okay, so basically the thing you have to understand is it is hierarchical things. So in order to figure it out, the problems like that, who is your grandparent or the great great grandmother or something like those kind of situation, you can really use trees. So HTML play page layouts also using DOM trees. When you are using AI, so something like that AI based thing, we are using decision trees. Okay, so we have figured it out from if you are black, then what you have to do. If you are white, you are have what you are going to do. So those kind of decisions you have to use in decision trees when you are using some sort of let's say Lexian based algorithm or something like that, where if it is positive, polarity is positive, then what to do, the you have to say the good output. If it is negative, you have to say something bad in your AI chatbot or something like that. You can use decision trees like that. In order to use those kind, most of us we are using is JSON type answers, solutions, sorry, datas. So JSON based data, the object based data, it will be easily tracked based on that. So in the trees, you can use decision trees. The typical thing that I have drawn, that round thing and the dash part, those are the representation of how the trees are working. So those are we are calling as binary trees, dictionary trees, or something like that. Dictionary trees we are mostly using in the folder structure, right? In the folder structure also there is a tree, right? So you are creating first as the assignment 0.1. In there is a UML folder. In the UML folder you have your architectural designs like the use case diagrams, use case scenarios, sequence diagrams. But in your code folder, you have your coding application. In your GitHub account, that GitHub folder, within that GitHub folder, you have your application name, then you have git files, something like that. That is, we are calling as dictionary tree. They are mostly used in fold structures we are implementing. So these are how we are going to use trees. So if you are getting any sort of problems regarding those things, that figure it out, what is the connection between something within above, you have to go with the trees, and it will give you a very, if you used BST like binary search trees, and it will be give you a search in some sort of a data is all again, or inserting data something like same similar all again. All again is definitely better than that. The developers hate part that on to the power 2, like something like that. So insertion and deletion search in the list, it will take around on is also better, but when you are getting a bst or uh, binary some sort of a tree, the insertions logins, it will get really fast. But sometimes when you are getting some sort of a, let's say multiplication or something like that, that's going to be really hard in the tree. So in order to figure it out, some sort of a relationship between some sort of a data and put in those data, it's definitely good to use that parent child, something like that. So there's only options you have is trees and decision tree, sorry, graphs, something like that. But a graph situation, you have to, I will talk about later. It will have a lot of different application to use where if you require a graph, because graph is more complex than trees, when you have to use it, and you have to be really careful when you are using those kind of things. So in the trees, so I have to tell you that if you require some sort of a relationship, parent-child relationship, you can figure it out. Okay. So for example, the finding the diameter of the tree, the longest distance between some sort of a two nodes. Okay, if you won't figure it out, those kind of things, normal situation, there is no connection. So you have to build the connection. If you are using array or something like list part, you have to first build the connection. That means that you have in the bookshelf, you have to put the labels in the every part, and then map all the label into your books, and then find the solution for that one. That will be a long round. So if you are using a tree, there is a direct connection between those two nodes, then you can easily figure it out, what to do, what the connection, what will be the distance. So this is the eighth book. So it is the longest book in there. The first coming, the first book is the first one that came first. So you have the connection between first to eight in the same node, or the uh, I told you that the typical tree you have used, there is a two nodes, right? Left and right. So you can figure it out which one is the going to the left side, the last one, or the right side last one. So you can figure it out easily. So there is a multiple depth first and breadth first, or something like searching algorithms that we can use. Okay. So if you are using trees, in order to figure it out the longest distance, we can use those kind of things. Even heaps are best solution to figure it out those things, but heap also basically a uh, binary tree, that optimized version, that you will in your university level you will read about lot of type of trees. Okay, binary trees, red, black. So there's multiple that heaps and letters on, but basic understanding is that you have to have is, if there is a relationship between some sort of a connection in the same hierarchical scenario, in order to solve those kind of problems, tree is the best solution for you. So if you understand how the connections are working, then you can give a better solution for those kind of problems. Okay. So that is the simple thing that I have to tell you about the trees and upcoming competition. Careful how you are using that. There will be multiple scenarios. You think these parts are best, but when if it is has a some sort of algorithmic addition or multiplication parts, it's best to avoid trees, because it's going to mess the situation more, when your solution will in the end of the your solution, until you are going to the end of the part tree, you feel like that using tree is the best, but in the board at the end you will figure it out. Okay, I couldn't figure it out, what are the edge cases, I will find out the answer, but this doesn't the answer that I require. So think about when we are using the right tool, it's come to the again to the back to the first point, that choosing the right tool. Okay, so that's about trees. Then this is the one, graphs. So why we use graphs? So do we have a lot of problems using graph? Okay, most common the graph that we are using, if you have a problem, most common thing is figure it out if you are lost. So what that mean is, mostly we are using graph to figure it out if we are lost. So the best answer is, let's say you are riding a bicycle. Okay. So you are age of, let's say, 10, then you have a bicycle. Your parents said you can't go past this junction. You have to come home, something like that. But you are not listening to your parents, and you are going beyond that junction and figure it out roads, how the roads are going. Okay, then you are past some sort of, you are going everywhere, every junction, turn right, left, and something like that. Then you come to a tree that you have already seen. Then you change the direction and go there and again come to the same tree. Then you figure it out, okay, now I am lost. Then I have to figure it out how to go home or some sort of a area. So this is the this is the situation that we are using graphs. Okay, that's why we have maps. In the past, we can ask some sort of a person and uh, let them how to go to there, and he will direct us to go to the that sort of solution. But after the Google Maps came, we get our phone and put the location and go home. That if think about that, if that Google Maps also show you the same direction, let's say you put that you are going from the car and put the Google Maps, but you are riding a bicycle. Definitely, you will go some sort of a round way and go your home backyard, and you can't figure it out. Come to home again. How to come there? You only see your backyard in the from someone else road. So if you put like that, that kind of situations we can solve using graph. So we can use those edge cases. In here you can see this combination, right? So if we go to this node to this one and again for there, what happen if I have some sort of a connection from here to here? Then we will come to the same location, right? Same junction. Okay, now we are in lost situation. So in order to figure it out and avoid those things, we are using graphs. Okay. So this is the fundamentals of graphs, the common usage of the graph we are using. So I will tell you where we are using that. I think you all have used npm package, right? So for example, let's say we need to have a npm package to convert these images into some sort of a format we need. Okay, so we have one beautiful npm package that required another npm package to install first. Same as Python, we need pip, some sort of a library to install something. Let's say this library required this library, so some sort of a different MATLAB library. Okay, so then this library say I am using this kind of library first. Then you have to install this in first. Then I will use this one likewise. So what will happen in here? You will never install the library properly, right? So in order to avoid these connections, we have to graph this connection, figure it out. Okay, this is going to a loop, so we can't build this npm package using this one. The reason is when we are developing this npm package, we never think this npm package will be used for this kind of application. Okay, so let's say this npm package has used this npm package. Though when we are developing this npm package, we doesn't think that this kind of npm package will use my npm, the library I have created. Basically, npm is library, right? So when the developers developing this library, they doesn't think that this library is used for this kind of situation. So these developers also thinks, okay, we have developed this one and we did our application from there. This is working fine. But they will never know that this kind of application will be used here. Okay. So they are trying to use, they require this kind of library. So when the development happen, they will come into some sort of a mess. Okay, if someone use this library, he will never able to install this properly because my library need this library need this. So it will be infinite loop. He will be suffering for infinite loop. So this kind of situation, in order to understand this situation, we use graph. So I think you have get an idea about when to use the graph. I will tell you with another example. So for another example, let's say you have to learn about some sort of a mathematical uh, subject, relevant subject. Okay, maths. Let's say maths. We all learned in the school maths, but we never used most of the parts, right? So we need to learn some sort of a concept in the maths. So it required some sort of a physics part that some sort of a PhD person has built. Okay, figure it out. So when we are learning about this one, we have to think about molecules and everything. So this will lead to us to learn about chemistry. Okay. So chemistry, when we are learning, then okay, in order to learn this, we have to learn about physics. Okay, then when need to learn about this physics part, or there is a some sort of molecule situation, so we have to learn about chemistry. So in the chemistry, when we are learning to some point, let's say 60% we have learned there, then in order to find the 61%, we have to have learn about how this connection between sorry connection between the let's say some sort of a percentage wise, you have to mix this and mix this to get some sort of a coloring. So in order to figure it out what is the percentage and something like that, you have to learn about maths again. Okay, you can see right now, right, we are in a loop. So it's mean if this one will be a subject in the university, you will never going to get a pass because you are stuck in this loop and you can't get out from here. So in order to avoid those situations, that's why we are when we have combined maths, we always figure it out what is the value of x with the alphabetical orders. In the chemistry, we have the get the solution. In the physics, sorry, in the chemistry, we have to figure it out the colors, patterns, and everything differently. If they mix these things out, when you are doing some sort of a physical science or something like that, you will figure it out. There will be no end. When you are learning maths, you need physics, you need chemistry, again, you need maths. You will be infinite loop there. So, those kind of situation, let's say the problem present like this, you have to avoid those kind of pattern, the infinite loop. You have to have a better graph of your syllabus, right? So, in order to graph that syllabus in order to have a structure in the syllabus, you have to graph this syllabus. So, when you graph that one, you can avoid these kind of patterns as well as Google Maps. If you are Google Maps, if you search A destination to B destination, if it is show you a loop, you turn in the every time it goes, it's going to be a mess, right? When you are developing those kind of map situations, you have to avoid this deadlock. You will get some sort of this kind of data. Later on, I will tell what is this one. Then this will gives you some sort of later you will use we are calling a zookeeper. Okay, zookeeper, Apache zookeeper. Maybe you have an idea, but if you don't, it is the connection between servers. Okay, so if it is who is the leader in here and figure it out. If you didn't use some sort of a syncing up situation, you will end up something like this, that connection between there is a connection between and every server, but you have in an infinite loop sharing data everywhere, and you will never find solution for that one. In order to solve this one, you have to first graph your servers into some sort of pattern and figure it out what are the deadlocks and what are the loops, and you have to avoid those situation in that path. So we used graphs for those kind of situation, and in the graph there is two types actually, uh, undirect and direct graph. So undirect graph is that edges we can go both ways. So it's something like this. If you have 2 points, your connection get either this way or this way. So directed graph means you can go have some sort of a direction like this in here. In there is a direct connection for that one. So In order to figure it out, that cycle paths in these two, we easily can figure it out which one is the in here, because there is a two-way connection. So we can tell this is a infinite loop if we are getting put like this. But if it is a direct graph, you have to go to multiple nodes to figure it out if there is a loop in them. So when you are using a type of graph, you have to be careful what you are going to use and what is your application, and what is your problem that you are going to solve. Based on that, you have to figure it out which type of graph that you are going to use, and based on that, you will find a solution to your problem. Okay, can show you some sort of a hash circle that we are getting. So this is something that going to figure it out, that this is undirected graph. Okay, so in here we are calling DFS, undirected graphs. So in here we can, when it is going to true, it we are finding the circle. So we are going to get the every visited node, and we have used in here arrays. I will talk about, we can replace this we using we are calling it as hash tables, but in here we are getting every neighbor node and as well as what we have visited before. So from there we can figure it out which one was the cycled that we are going to get. Then based on this answer, we can give you some sort of a solution. For if it is true, then we can tell avoid this one or something like that. Okay, so if you require these kind of, I think this code are just for your explanation and you to see how the graphs are working. So if you require this code, please let me know, that I will upload this in somewhere you can see. But these are for your example. This doesn't have any thought of thing. This is just giving you how the codes are working, what I have said you before. Okay. So that's about the graphs. So if you requires a directed graph, uh, so it's something like this. Okay. So in here you have to be extra careful. In here we can easily go through that part, but you have to have a restack method and going again, whether if it is found or not. In here you can see we didn't use something like that undirected graph. We doesn't have to give extra careful with how where they are going, because in the two-way connections it's always be some sort of level of loop situation, so we can easily figure it out which will be the loop. But in the directed graph, it's going to be, we have to keep track of every movement we are doing, then figure it out which part going to be a hardest part, loop path, and we are remove it from there. So if we are using directed path, that mean it is really well structured. But we are using undirected graph, we are there most of the time that we don't have an idea whether if it is come back or go again. So in those kind of situation, we are using undirected graph. But if we have a clear understanding, okay, this will happen to an after this one, like this is the third session, we will never do a second session after the third session, right? So in that cases, we are doing the fourth session. So there is a clear path of how the things are going, but in some problems we doesn't get an idea whether if it is going that way, no, or not. Like in a bicycle, we are going some place, we can miss that situation, right? Junction and go to the, and we have to redirect the vehicle to the another situation and figure it out, remove the loops and everything that you have to go through. That we don't have an idea that customer will always go through the thing that we have always said, right? Maybe he can put an u-turn and come back again. So in those kind of situation, we can't use always direct graph to map those things. We can use undirected graph to those kind of situation as well. Okay, so those are the things, and these are the codes. I will give you some time if you required. I will upload these parts in that some sort of a GitHub link or something like. Then you can see these things if you require. And these are the things normally the difference between the direct and indirect, and the situation whether where you can use those things. Okay, so the summary of this is that network and connectivity, the graph can, if you have a network and connectivity, which then each task that you are doing, and there is a no, if it can have a parent child connection like trees, but if you need another more connection, let's say you married someone and you also another have a girlfriend or something like that, you can't put it in the family tree, right? So you have to have some sort of a different line for that part. So in those situations, better to use graph. Okay, I have these kind of these things. Okay, then you can not these things. Sorry, these kind of situations. So I can do so if it's in the money saving part as well. Some expenses you can track, but some other expenses, if you put it to some sort of app, you will call some person will call the police and tell me they will spend something, some kind of amount for this person. So in those situations, you can't use the tree based things. You can use graph. Okay, from here I will put like there, and we can connect each part. Okay, so those, if there is a connectivity between that without having some sort of parent child connection, you can use graph even if had a parent child connection and another connection with those parts. You can definitely use graph for those kind of situation to solve. Follow. Okay, so the next one is sorting. So sorting, what is that sorting? You have heard about merge sort, then again, um, multiple sort in algorithm, bubble sort, and everything. Why you have to learn about multiple locations also? If you are using Python or something like, you are putting array and put a dot sort and it is sorted. You don't know whether if it is a bubble sort or any kind of sort. Why do you think this sorting will be what you need from there? So the order and the optimization, right? So we are using this sorting in different ways, different applications we would like to solve. So it's like something like this. You have a computer place, right? You have a computer and you have a second monitor, third monitor, and maybe you have a machine besides you, and your clothes and yesterday clothes and the yesterday drink that you have put, and there is a table that really messy. Okay, for the same person, let's say you have went to a university and you are studying, then you forgot it out that you forgot your university ID. Okay, then you are telling your one of your friends in the who didn't came to the lectures, and okay, maybe he doesn't have lectures today, to go and get your ID from that desk. Okay, now he is in a big trouble because the desk is a really messy place, so he can't figure it out where it goes. So he is going through every part. Then there is a risk, right? So he can find out something that you don't need him to find out. Or you can say that he can't even enter the room because of the door is blocked with that messy place. Oh, so in order to avoid those situations, it's better to have some sort of a ordered or optimized situation. Okay, but that person maybe have a better computer which organized your folders into best categories and putting everything there and that, but the room is a mess or something like that. But it can be any situation, but in the thing I am telling is that some figure it out some sort of a situation in that kind of mess place, it's going to be really hard, right? So it's best, even if it is a data, let's say a array or tree or graph, not graph, array or tree, or let's say we are calling hash table. I will talk about later. But so something like that, at least better. It's better if we can sort it out first, and then whether it can be ascending or descending order. We can, if or it is some sort of pattern, we can sort it. If we sort it out, it will be easier to grab something from there, right? So from that previous example, if we organized our table or our room, it is easier to someone else to figure it out. But it need to be the thing comes is it need to be done by you. It's mean it need to be done by some level of algorithm, right? The reason I'm telling is that we face this situation, right? When we clean the room, we put something in some places, we can easily figure it out. But let's say your mom clean the room, you have to ask your mom where she put that one, right? So it's going to be different from each and every application. That's why we have multiple sorting algorithms, bubble sort, merge sort, something like that. We can combine them with some level of algorithm, and we can create a better sorting and optimizing situation based on the situation we are in. Okay. So like that, if you are in a chemical industry, so we have to figure it out that there is a multiple nozzles, and we have to put a 9 millimeter into some sort of a pen to parts that. But if the nozzles are in a different order, the machine has to rotate in a different mechanism, right? So always that will lead to some sort of a heating problems, some sort of maintenance issues, something like that. First, you have to get the things and clean the place, then give the solution for those. So in the problem solving, these sorting parts come as a not an solution, but it will help us to go to the solution. Okay, that's why in data structures and algorithm, there is a specific topic talking about multiple version of sorting algorithm. That some people say there is a postman that who put the postman like that. You will learn about this in a very deep later in the your university life, or mostly in the university, or if you are using if you are in the you are doing your MSc or doctorate, in those situations you will talk about this. You will learn about this more. But if you are in the development environment, we don't directly use these kind of words, but we use in some sort of architectural design that telling what to do from there. Or as far as we are using flow diagrams to, okay, first do this and then go to that part. In order to do those things, we will use a different term in the industry than the academia uh, in the long run. In the competitions, the sorting will be help you to figure it out the answer later. So you will get some sort of a data list. First you have to sort it, then you can categorize into some level of things, then output the answer that you have required. So those kind of situations, sorting will be really come with handy. So for example, let's say you have to figure it out the what is that you have $10. Okay, so within the $10, one is there is a price tags in the process in the shop. Then you have to figure it out. You only have to spend $10, but what are the items you have to get? So when the items are in some level of different places, it is going to be really hard to figure it out how to get at the $10. But if you sort the items in a place, okay, this is $1, this is second, this is 100 rupees, this is 200, 300, 400. If you have 1,000, you can figure it out. I can buy a 100 rupee one and the 900 rupee one. Then my $1,000 is well spent. But if you doesn't require the $100 one, if you require the five and four, three and two, oh, you can figure it out which are the parts you have required, right? So those kind of things doesn't done by sorting, but in order to if you sort that part, it will be easier to you to make some sort of a decision. So when you are in the programming competition, when you got a problem, if you can sort it out very well first, then you can figure it out how the decision can be made. So it will be even help your memory optimizations as well. So it will lead you using different techniques rather than what you have thought previously. So normally when you are getting a problem, we doesn't give an exact solution at first. First we try some solution, then we figure it out it doesn't contain everything, then we optimize it, and we figure it out, okay, if we did this one, that will be best. Okay, so in order to help those situations, sorting will be a really good approach if you can do that. But everything doesn't, yeah, every question you can't sort, but that will be help most of the questions if you go to this kind of sorting mechanism first. Okay. Okay. So hash table. What are these hash table? Hash table, the best uh, example I told you is your contact list, basically. If you want to search your any relations or something like that, you can just your name and get his contact number, right? So when you are typing your name, it doesn't give you some sort of a different thing, right? It just gives you the phone number and the details that they require. Okay. So in the hash table, it works like this. Okay. So let's say there is a name and there is a number you have here in the contact list. When you put your name, let's say Alice or something like that, so this will contain the hash table has a hashing function. Okay. So hashing function convert this Alice into some sort of a digits like this or something like that. It's depend on the hashing function you are using, but the basic hash map has a hashing function. When you insert a name, it contains some digit and it's combine it with that your number. This hashing number is contain the name you have Alice plus your number in a different pattern. When you are looking at, let's say you are using this to get the number back. So this when you type this is looking for this part. So then it figure it out, okay, this is this, and from there it's output that number you have saved. That's how the hashing works. Okay. So when you are first saving this one, you have saving your Alice and your number, and this will be converting into some sort of a digit with the combination with your number, then it is saved. Where then when you are accessing this name again, it doesn't get and go and search the Alice, it's searching for this number. Then it will output the number, the value that you have saved based on this name. So that is the hashing is working. So if you want to create some level of dictionary, or if you are using some sort of a contact application, this is the way you can use. The best thing is the searching of this one gives you O1. This is best, right? So if you are getting O1, it means there is no another optimal version there. So one is the very first one that we can use. That finding is really super fast. When you are using the hash tables, you can just put the names and numbers and you can do it. But what is the downside is that in an array, we doesn't require to know some sort of a name in order to get some sort of a value. We can just put an index and get the values, right? So, but the hash tables, you have to have an idea whether if it is exist in that part, otherwise you are getting non-existing error, or otherwise you doesn't get any data. So if you have an idea whether this is exist in the table or something like that, if data is present there, you can easily access within a small time. The reason is that if you want to access 2 in an array, you have to put an loop and figure it out. If the 2 is exist, then give me the 2. But in here, you can just put a name and figure it out. Okay, is 2 exist? You can get an answer, the value. Otherwise, it will get a empty. There is no data. So you doesn't have to go through a loop and figure it out because there is no loop, right? So using the hashing map, there is some sort of code. It just accessing this one and getting you the answer that contain there. So normally, uh, in here it will it look like a object basically. So if you have a context, it's like you have saved your number like this and it is accessing this and give you that object from there. So you can easily access like this. Like this, if it is present, you can put these values and you can print this value as well. If you are using Alice or something like this, will output the Alice word easily without going through any sort of a loop to whether we have to Alice is exist and getting like that. If you know the you need some sort of value, you can directly access it. Otherwise, if you are using some sort of array or something like that, you have to check whether each index, whether if it is exist or not. Okay, now in the second index the value is present, then value need to be output, something like that. You have to check it out. So it's going to be really hard when you are using some sort of a application, when you know there is a data is present and you if you want to directly access. But if you save those things in array or something, even it's a tree, you have to go to the each tree, each node and figure it out. Okay, in here this node, this table data is present, but in the hash map you don't have to do that. Just type the keyword, then you will get the output from there. Okay. Okay. So that is all about hash tables that you have to know when you have a present a problem. You can easily solve it from using that. If you require just to get the data, you can use a hash map and get the data really fast. Then you can do so. Hash maps, hash tables are basically using for uh, quick access data. So if in this matter I will show you like a CLI, but in the industrial in the industry we are using like name servers, right? Name servers means there are multiple servers, multiple. If you are developing a microservices architecture, there are multiple servers and multiple clients, right? So multiple clients are accessing the same IP address and the port. So if you let's say your server just change the port for some time because some sort of a port requires some sort of attention. So if the port change, the client doesn't know whether the port are changed or not. So in that cases, we are developing a service called as name servers, just saving all the servers names and ports. Okay, when the clients are accessing this one, any sort of a server, he is checking with the name. If first he tried to access the server IP that we have given and try to retrieve the data from there. But when the client trying to access the data, that if the data is not coming, then client is automatically calling to the name server and check whether the port is changed or not. So in the name servers, they are using hash tables, just name server name and put in the IP and the ports there. That's the only thing that mostly name servers are doing. So they are accessing that when okay, then the value is changed, then clients are changing their ports as well. Okay, I have to change our port to get the access to this server. So server has changed. So in those kind of microservices architecture scenarios, we are using those distributed, mostly not microservices architecture. There are multiple services as well. Distributed systems, we are using the name server to access with the client and server. It is a very small server. Normally, I think etcd or something like that already exists, and you can just run and write one script and develop something like that. So in those scenarios, we are using hash tables to store our server names, IPs, and ports in order to access from the anywhere in the clients. Okay, so that is a one real application scenario. We are using the hash table, not the base level. Let's come to combined structures. What is that? So combined structure is that most of the problems in the competitions, you are getting that combined problem, right? The hard problem. It has a multiple structure. So if you are getting the hard problems, or if it is categorized in hards, most of the problems they are trying to put you away from the actual problem. Okay. Then they are using multiple structure to do that. So they have created some sort of a background story. Then they have used some sort of a, let's say, encoding part. Then the first they are trying to move you away from the real problem. Maybe it is a really small problem that if they directly gave you, they are trying different structure to keep you away from the real problem, to waste your time or put your time to figure it out how to come into the real problem. So that is a one skill as well you have to have. So you have to have a real skill to figure it out. There are multiple structures, so you have to merge all these structures to figure it out how to solve the challenge. So you have to have a basic idea about the structures they have using, and when you combine those structures, okay, you can figure it out. Okay, this is the real problems I'm going to get, and I can figure it. I can give very advanced solution for this one if I decode it this way. Okay, so it's in the data structures as well. You have now I have told about trees, arrays, hash tables, routines, and everything, right? So if the problem present you with multiple structures, it means you have to solve it using the multiple structures as well. So that means you can just put an array and solve it. You have to combine the array with some sort of a sorting algorithm or some sort of level to, in order to get you the relevant solution for those parts. For example, we call LCA. LCA, we have a memorization options. LCA means lowest common ancestor. So we are combining trees, the trees algorithm with hashing. So when we combine this one, it is called as LCA with memorization. LCA means lowest common ancestor. So lowest common ancestor in the tree, the basic idea is you have to figure it out which was the lowest node in that application. So it's mean you have to use a tree to figure, if there is a node, it means you have to use a tree or a graph. So you have to figure it out which one you are going to use. So if it is a very basic connection with the parent and child, you are going with the tree, and you are combining the hashing method in order to solve those questions. So that's one thing we are calling it as LCA. Uh, So if it is LCA, you can directly use node systems or node based thing and figure it out. And there is another common thing that's come, that uh, Kruskal's algorithm, like MST. MST means minimum spanning tree. So in here also it is minimum spanning tree. It means it is a greedy algorithm. So greedy algorithm is something like that. What it call like a very misleading algorithm to solve that. So there is a name as well, Kruskal's algorithm. When you are using that, it is known as one of the greedy algorithms. You will learn about greedy algorithms in upcoming situations. But it is like some sort of a sorting mechanism with figuring out the edge cases. So if the edge cases are iterating all and again, so it is, we have to quickly remove those edge cases and figure it out solution, something like that. So if the connection of the all the things, that let's say you have to put an internet connection, the problem present, like you have to put an internet connection for all of the city. So the first thing that, okay, there is a city, so there is a internet connection I have to provide. So we have to avoid that loop part. So I can use trees, but there's no connectivity within that looping situation in the tree. So I have to use a node situation, but there's only two options, graph or trees. Then I can go with the graph. Since there is a city situation, we have to put some sort of a network connection all over that. We have to definitely avoid those looping situation. Then the graph is the better solution. And when we are getting that all over the city connection with all the paths, we have to combine it some sort of a sorting algorithm to, so we can minimize the length of the cables from there, and we can give some sort of optimized solution for that. Okay. So for example, that I told you that cities has internet connection, most companies try to give you the uh, smallest length, right? Otherwise it's going to be costly, right? So they are like to be cost effective ways. So first of all, they have to figure it out to how to avoid those looping situations. That's why we have used data structures. And in order to save money, we have to use the shortest path. So we are using some sort of a sorting algorithm. When we combine graph and sort, we automatically, there is a algorithm, greedy algorithm presence. We call it as Kruskal's algorithm, as well as MST. Mean MST means, what is that, minimum spanning tree. So you can use that one as well if you are figuring out some sort of a solution for that kind of problem. Okay, another common combined structure we are using is arrays hash map with prefix sum. Prefix sums means we have to figure it out largest sub arrays or something like that. So in that case, it's better to use arrays which hash map. So we can save where we have gone before in the hash map, and we have our data in array. So combining with these two, we can figure it out some sort of algorithm to break it down and calculate the total about this and storing those things. Okay, there is an array. First of all, we can store those data in this array as a simple solution. Then we use some sort of algorithm like prefix sum or something like that to calculate something, and from there we can store this. Okay, I have calculated this as a is this value. We can save it in a hash map, and later we can use in this hash map. It is really fast, we know. So we can output the value that we have stored there and give a solution for some sort of problem. So those are the most common three patterns when the problems are presented. Okay. So we can connect the graph with some sort of a sorting algorithm, or we can have a tree with some sort of a hash algorithm, or we can have some sort of array with some sort of a prefix that calculated algorithm that we can get our totals, or the we can get some sort of a connection from there to there. So those kind of things with when we can, and we can save it on the hash map and output. That will be the best three solutions with any questions, any problem that will come up in the uh, even if it is a coding interview, or whether if it is a contest as well. So I think I have covered all three structures in there. So those are the combined structures you can go with to solve the problems that presenting with the multiple structure that hard named as labeled as hard questions. And finally, I will give you some tips to problem solving that everyone's giving that. First of all, I think don't try to copy all the problems and put the chat GPT and get the answer. Try to understand what is in there. First of all, if you don't have any idea in the problem, first understand what are the inputs and what kind of output you require. In the IT industry, that is the base thing, inputs and outputs, and middle, you have process. So first of all, try to understand what are the inputs and outputs, then try to figure it out what are the things that you can do to it. Then try to visualize some sort of told you that array is the king, that everyone goes there. When you hit the second for loops, try to change your data algorithm. Otherwise, if you figure it out, okay, I need 2D arrays or 3D arrays, try to change the data structures, try to visualize your data structures that you required. And it's fine starting with the brute force, try it every single thing, then optimize it later with the different patterns like that. I tried with the array, I hit the 2D array, or I hit the second for loop, then I change it. So first of all, I try to go with the brute force, then I change the pattern. So, and the second one is practice. Normally using lead code or hacker rank or something like you can practice the questions. Even the IEEE, they are CS Academy, right? I can't remember. I did the extreme in 15 and 15.0, 16.0, something like that, 14.0, something like that. In those cases, we are practicing in CS Academy as well. So you can practice every day and you can familiar with the answers and patterns, how they are using, what are the optimized ways to do things. So that these the competition that you are doing today mostly help you in the future to get some sort of a job, as well as in within the job you can easily go home at 5 o'clock. Otherwise you will I have my friends as a developers who are working around 3 a.m., 5 a.m. because they didn't do much in the university life to figure it out how the things are working. If you want to go home at 5 or earlier, it's best to understand how the basic concept are working, how the data structures, how the patterns are using, then you can rest within the day as well. Okay, so today I think I have covered all the planned thing what I have done. And do you have any questions regarding this one? I think chat. I couldn't check the chat. Please put if you have any questions, you can put any chat, or if you are shy to. Is there any sort of a platform or something like that we have questions or something? No, right? Chat. I think Zoom chat is available. Okay, let me know if there's any sort of a questions regarding.
If any of you have questions or need clarifications on anything discussed, please feel free to ask. Are there any questions? Okay, finally, as we wrap up, I would like to take a moment to express our gratitude. A big thank you to Mr. Sasanga Veerakon for taking the time to share the expertise with us. We truly appreciate your insights, sir. A special thanks to our organizing team for making this event possible, and of course, to all of you for your active participation. We hope today's session helped you build the algorithm and code like legends. We have 4 more workshops lined up on dynamic programming, game theory, and computational geometry. So stay tuned for deeper dives into these fascinating topics. Stay connected with us through our official channels for updates and more exciting sessions. You can find all the links in the chat. Until the next time, keep coding, keep learning, and see you soon at our next session of ALGO Ace. Thank you.